Let's begin our Hadoop and Spark demonstration by launching the Spark shell. As you can see, we're connecting to our Hadoop server, and Spark is initializing with version 3.4.3, running on Scala. Notice the startup meshes. Spark is configuring itself to work with our Hadoop cluster. The system is setting up the Spark context and making it available through the web. Now, we have our Spark shell ready with the Spark session available, and our Hadoop cluster is fully operational. This gives us the foundation to demonstrate both technologies working together. Excellent. Our Hadoop servers are now fully operational. You can see we've successfully started all the core components, the name nodes on localhost, data nodes, secondary name nodes, resource manager, and node managers. The GPS command shows us the running Java processes. Each number represents a different Hadoop service that's now active and ready to handle our distributed computing task. Now let's explore the Hadoop ecosystem through its web interface. Here we have access to the Hadoop name node information page. This is the heart of our HDFS, the Hadoop distributed file system. The overview shows our cluster is active and healthy, with key details like the cluster ID, version information, and system summary. Notice we have 43 total file systems, objects across 15 blocks, and our DFS is currently using about 369. Let's browse the HDFS file system structure. We're now the root directory of our distributed file system, where can we see three main directories: data, health data, and user. This web interface allows us to navigate through HDFS just like a regular file browser, but remember, these files are distributed across multiple nodes in our cluster. Drilling down into the data directory, we can see our sample dataset ready for processing. Here we have several CSV files, including globalhealthstatistics.csv at 128 megabytes, perfect for demonstrating big data processing capabilities. Notice how HDFS shows us details metadata like file size, replication factor, and block size for each file stored in distributed system, confirming our data is properly distributed across the Hadoop cluster. Great. Here we can see additional files in our environment, including Python scripts for health data analysis and Spark processing. Notice the healthanalysis.py and uploadhealthdata.sh scripts. These will help us demonstrate the integration between Hadoop storage and Spark processing. Now we're submitting our Spark job using Spark submit healthanalysis.py. Watch as Spark initializes and begins processing our large dataset. You can see the Spark startup message as it configures the execution environment and prepares to distribute our computation across the cluster. Our Spark job is processing the health statistics data and showing real results. We can see country-wide health data being analyzed, including disease prevalence rates, mortality rates, and other health indicators. This demonstrates Spark's ability to handle complex data transformation on large datasets. The processing continues with Spark performing aggregation and calculations. Here we can see the top 10 countries with their health statistics, and below that Spark is calculating average mortality rates by disease category. Our analysis is producing valuable insights. Spark has calculated average mortality rates across different disease categories, including metabolic, cardiovascular, neurological, and infectious disease. The job is completing successfully, and we can see memory management information showing how Spark optimizes resources usage throughout the computation. Spark job is finished up. Notice the cleanup process as Spark stops various components and clean up temporary directories. The Spark context is being shut down, clearly demonstrating proper resource management in a distributed environment. Finally, let's verify that our processing results have been saved back to HDFS. Using HDFS dfs-rls/data, we can see our original input files are still there, along with any output files generated by our Spark processing. This completes the full cycle: data storage in Hadoop, distributed processing with Spark, and result persistence back to distributed file system. Our Spark job has completed successfully. Notice the final cleanup message as Spark shut down all the components cleanly. The system is deleting temporary directories and stopping all services properly. Most importantly, we can see our output files have been created in HDFS. The pop-by-country.csv directory contains our process results. Let's examine what our Spark process produced using HDFS dfs-cat. To view the population by country results, we can see our analysis has generated meaningful insights. Data shows population statistics for countries like Russia, Germany, South Africa, and many others. Exactly what we were expecting from our distributed data processing job. Now let's move to the visualization layer of our big data stack. We're accessing Grafana, a powerful monitoring and visualization platform that will help us create interactive dashboards from our processed data. Here the Grafana welcome screen shows our monitoring and visualization environment. Notice we already have the health stats dashboard in our recently viewed dashboards. This demonstrates how Grafana integrates with our data pipeline to provide real-time insights and historical analysis of our processed health statistics. Our health statistic dashboard is displaying the results of our Hadoop and Spark processing in beautiful interactive visualization. On the left, we see population data by country, with Russia and Germany leading the chart. On the right, we have disease specification statistics, including cancer, leprosy, dengue, and other health indicators. Behind the scenes, we can see how Grafana connects to our data source. The dashboard is configured to query our processed data with SQL queries like select country population affected from pop by country, pulling data directly from our Spark process results. This shows the seamless integration between all components of our data ecosystem. This completes our comprehensive demonstration of Hadoop and Spark in action. We have shown the entire big data pipeline, storing large datasets relatively speaking in Hadoop distributed file system, processing them at a scale with Spark, in-memory computing engine, and visualizing the results through Grafana interactive dashboard. This powerful combination enables organizations to handle massive datasets, performing complex analytics, and gain actionable insights from their data, all while maintaining high performance and reliability through distributed computing principles. This demonstrates a production-ready big data architecture that can scale to handle petabytes of data while providing fast interactive analytics and visualization capabilities.